Welcome to qnawire.
We are asked to construct a Born-Haber process diagram in order to show the formation of a hypothetical compound, NaCl2. We are told that Na has a fake 2 plus charge. And the second ionization energy I will provide in a couple of minutes. We are asked how large the lattice energy would need to be for formation of NaCl2 to be an exothermic reaction. And we are asked to estimate lattice energy if the heat of formation is about the same as Cl2. Which was given as 2,326 kilojoules per mole. And I think I'm going to go ahead and go to another page. I wasn't going to try to do it on this page, but I think I'll try to do it over here so I have some room to write. Okay, we're going to start right here. So we don't know this. We don't know the and I'll give us what we do know here. We do know that our heat of formation, the sublimation, is what will give us the Na gas and I know that this value is, I believe, 108. That one's 108 kilojoules per mole. Our second piece, our delta H of formation for chlorine gas. Now we've got two of these, so we're going to have to multiply that one by 2. And over here, that will be NaG plus 2Cl. And this individual value, is 121.7, I believe. And if memory's serving, I'm going to look this one up again. It's 107 point. I just abbreviated it there for some of my later calculations. Let me find where I wrote this down. 107.8 and 121.7. There we go. Our next piece will be our first ionization energy, and then a much larger value, go up to here, is our second ionization energy for sodium. And our first ionization energy will get us to an Na plus, and then a Na2 plus. And our first ionization energy is, I think that was 496, yes. And where a huge difference is going to come from is our second ionization energy, because our second ionization energy for sodium is 4,711 kilojoules per mole. Of course, that's because sodium has a stable octet after the loss of one electron. And moving down with our electron affinity, we're going to take 2 times the electron affinity of chlorine, which is negative 349. Kilojoules per mole. And this is our lattice energy. Since I don't know either this or this, I can do some calculations, and I'll show you that calculation in a moment. And in the second part of this, I feel like they should have asked me the second part first. We'll be able to come up with something a little bit different. So for here, our lattice energy is equal to, I'm going to leave my kilojoules per mole off so they all fit, my 108.7 plus my 2 times 121.7 plus 496, that's my first ionization energy, plus 4,711 minus 2 times 349, negative 349, plus our heat of formation for NaCl2. When I get done here, I get my lattice energy is equal to 4,711 kilojoules per mole which means my lattice energy minus this number equals 4711. So we can see, because of the numbers that I'm about to highlight here, this number is way bigger than anything else. Did I write that down wrong? I don't feel like 4711 is correct. It's 4562. My bad. I wrote the answer there, 4562. There we go. Then I'm going to erase this and fix that. That's better. And then that's what it equals. I just copied the wrong number down. I'm sorry. So from this, we know that the lattice energy from this value, even though that's doubled, that's minor. And even though that's doubled, that's minor. This is our big factor that changes our values here, because the second ionization energy for sodium is so unbelievably high. The difference between our lattice energy and our heat of formation for NaCl2 would have to be equal to 4,711, which means we'd have an unbelievably high lattice energy. Now, using this information, we are asked for our second part here to estimate this lattice energy Excuse my bad writing. Oh, I read that wrong. Estimate the lattice, estimate NaCl2's delta heat of formation if the lattice energy is roughly the same as mg Cl2, which was 2,326 kilojoules per mole. This one's pretty simple. We just substitute this value in. So we're going to take our value. Lattice energy is 2326 kilojoules per mole, equals what we had on our previous page, 4,700 minus your heat of formation. So we get our positive heat of formation of NaCl2, 4,711. I should have written 11 there. Minus 2,326 kilojoules per mole gives us 2,385 kilojoules per mole. Making that assumption. And I believe that is it.